Good morning, students. This lesson is of class 10th for the subject of physics, topic work, which is covered in chapter 2, Work, Energy and Power of your physics textbook titled Concise Physics by Selena Publications. Students, today we will study about first term of this chapter, that is work. Now, children, work is said to be done only when the force applied on a body makes the body move. For example, if there is a notebook lying on a table in front of you, suppose there is a notebook lying in front of you, and if you apply a force on it, then what will happen? If we apply force, then what will happen? Of course, this book of yours will be displaced. It will be displaced from its position. So when you are displacing an object by applying force on it, then we say the work is done. So children, work is a scalar quantity. It is a scalar quantity. And mathematically its formula is given by work done is equal to force multiplied by displacement. So today we will study about this term which is known as force. Children, if we apply a force to push a wall, then what will happen? There will be zero displacement. Can you move a wall? No. So if you apply a force to push a wall, then work done by us is zero because we are not able to displace the wall. Similarly, a coolie does no work while standing with a heavy load on his head, although he feels tired. Children, a coolie has lifted a weight on his head, but he's not moving, he's standing. He will feel tired, but since there is no displacement of the load, so again work done will be termed to be zero here. Children, the major formula which we do for work is not just product of force and displacement, but it is Fs cos theta. So W here stands for work, F stands for force, S stands for displacement, and theta will be the angle between force and displacement. So whatever the angle is between force and displacement will be taken as theta. Children, if force is applied making the object displace in same direction as that of applied force, then we say angle is 0 degree. Suppose you are applying force in one direction and the object is also moving in the same direction. Then the two, force and displacement, are acting along same line. So whenever the two quantities acts in same direction or are parallel to each other, we say the angle made between them is 0 degree. And children, cos 0 is how much? Cos 0 is 1. So as you can see in the joining diagram, the force is applied on a box towards left and object also moves towards left. It means that both force and displacement are in same direction and hence theta is 0 degree. And children, just remember that cos 0 is 1. What is cos 0? Cos 0 is 1. So if you put the formula Fs cos theta, this term will become 1. So hence the formula of work done can be written as work is equal to force into displacement. The amount of work done by a force is equal to product of the force and displacement of the point of application of force in the direction of force. And children, work is a scalar quantity. Remember it. Work is a scalar quantity. And SI unit of work is joule, while CGS unit is ergs. So children, let us find the relation between joule and erg. So yes, student, 1 joule can be written as 1 Newton multiplied by 1 meter. And Newton can be termed as 10 raised to power 5 dynes. And meter can be written as 10 raised to power 2 centimeter. So it becomes 10 raised to power 7 dynes into centimeter. Joule is SI unit of work, while ergs is CGS unit of work. Hence this dynes into centimeter is known as ergs. Fine. And if you have to define the SI unit of work, how to define? So let us see how can we define the SI unit of work. Children, first step is write down the formula of joule. 1 joule is equal to 1 Newton multiplied by 1 meter. So how to define 1 joule? 1 joule can be defined as the amount of work done if 1 Newton of force, 1 Newton of force is required to displace a body through a distance of 1 meter in the direction of force applied. Why we are writing in the direction? Because cos theta is taken to be 1, theta is 0 here. So in the direction of force applied. And similarly, we can also define ergs. Here, 1 erg can be defined as amount of work done if 1 dyne of force is required to displace a body through a distance of how many centimeters? 1 centimeter. So, through a distance of 1 centimeter in the direction of force applied. And relationship I just told you now, you have to learn this also. 1 joule is equal to 1 10 raised to power 7 ergs. 1 joule is 10 raised to power 7 ergs. So, children, now amount of work done, how much work you have done depends on two factors. Firstly, how much force you are applying, and secondly, how much displacement is done by the applied force. So let us learn case 1. Now if you observe the adjoining figure, if I apply 5 Newton force to move it a distance of 2 meter, and in the other part I am applying 10 Newton of force. So 10 Newton force is applied to cover a distance of 2 meter. So children, 5 multiplied by 2 is 10 joule. 10 Newton multiplied by 2 is 20 joule. So second, when you are applying 10 Newtons of force, you are doing more work. So similarly, if same force is applied, if both case 1 and 2, we are applying same force, and say the distance traveled is different. Suppose I am applying 5 Newton force in both cases, and in the second case I am covering a distance of 5 meter, while in case 1 I am covering with 2 meter. So here the answer would have been 10 joules in case 1, 5 into 2, while in the other case it would have been 25. 5 into 5, 25 joules. So children, I hope this is clear. Now, children, one more thing. We are having three categories of work done: positive work done, negative work done, and zero work done. Today we will discuss about positive and negative work done only. So kindly look on the screen, please. So what is a positive work done? Whenever a force and displacement are in same direction, then the work done is positive. Why? Because theta is 0 degree and cos 0 is 1. So the formula of work done becomes Fs. So whenever the applied force and displacement are acting along same direction, work done is positive. So students, if you see a falling object, if an object falls from a certain height from A to B, then what is the work done by the gravity? So work done by the gravity is work done. The formula of work done is force into displacement. Suppose when it is falling down, it is covering a distance of h meter, and a ball when falls down will have a force which will be equal to its weight, that is mg. So here the formula can be written as mg and h. So children, in this case, force, that means weight of the body, and displacement done by the body, both are in same direction. Hence, it is an example of positive work done. So children, take a break of 5 minutes and try to lift a box upward. What will you observe? Suppose you lift a box upward. So the force applied by you is also upward, and displacement is also in an upward direction. So what is this? This is an example of positive work done. Very good. So children, if you lift your bag or your geometry box or your mobile phone, all these are examples of positive work done. And one more thing, class, whenever an object is falling down, and then the work done by the gravitational force, or you can say the work done by the weight of a body, is given by the formula mg into h. mgh. Now children, let us study the second type of work done, that is negative work done. Now children, sometimes when we are applying a force, the displacement is occurring in opposite direction. Suppose I am applying a force in a forward direction, but displacement occurs backward. Then the angle between force and displacement is 180 degree, and cos 180. This you have not studied in mathematics. Cos 180 is minus 1. Children, kindly remember it. Cos 180 is minus 1. So when force and displacement are opposite to each other, which is also known as anti-parallel. If they are anti-parallel to each other, then angle between the two is 180 degree. And since cos 180 is minus 1, thus work done can be written as Fs cos 180, which becomes minus Fs. So I hope this much is clear, children. Now let us do the example. Children, suppose you are applying a force in a forward direction. Displacement is also occurring in forward direction. And in class 8th, we have heard that friction always acts in opposite direction to the applied force. So, if the motion is in a forward direction, frictional force will always act opposite. So, children, what is the direction between frictional force and the displacement? Aren't they both opposite to each other? And since they both are opposite to each other, therefore, frictional force, work done because of frictional force, is always termed to be negative. So, children, frictional force is always opposite to the motion, and thus, as shown in the diagram, frictional force is oppositely directed with respect to displacement. Hence, angle between frictional force and displacement is 180 degree, and cos 180 is -1. Hence, this is an example of negative work done. Children, in this example, work done by the applied force and the displacement. Applied force and displacement is an example of here positive work done, while frictional force and displacement is an example of negative work done. So in this example only, both the types of work done are included. It depends on which force we are talking about. Children, similarly, while taking a catch, a fielder takes his hand backward, but force applied is in forward direction. Here the displacement and force applied are in opposite directions relative to each other, making an angle 180 degree, due to which work done by the fielder while taking a catch is an example of negative work done, that is cos 180 is -1. Similarly, when a ball is thrown upward, the work done by the force due to gravity. Now children, this ball is thrown upward, but force done by the gravity always acts downward. So listen children, you are having a ball, suppose you have a ball in your hand and you throw it upward. If you throw it upward, what will happen? This ball will move upward. So the displacement is in an upward direction. And see here, what we have done, we have applied force in upward direction. Displacement is also in upward direction. So the work done by the applied force is positive because the applied force and displacement are in same direction. But children, now the displacement is upward, but force due to gravity on the body is downward. Force due to gravity means weight of the body. It is acting downward. So weight of the ball, work done by the weight of the ball is an example of negative work done. So children, with this, I am finishing your interactive session for this week, and you all are required to go through the notes properly and then read the topic from the book also. Derivation of Fs cos theta on page number 20 and 21 may not be done, and children, kindly do the tick mark questions, that is question number 1, 2 and 5 given on page number 27 of your physics textbook. Thank you, students.